Good evening, my YouTube viewers. In this video, what we're going to just talk about is another practice question, and it's going to be concerning hypothesis testing with estimation. And our practice question is, a company claims that their employees work on average of 40 hours per week. A random sample of 30 employees shows a mean work week of 38 hours with a standard deviation of 5 hours. At a 95% confidence level, 1. Test whether the company's claim is valid using a hypothesis test, and 2. Construct a 95% confidence interval for the population mean and interpret the results. So we're going to answer this question using Python. And in order to use Python, the first thing that we need to do is we need to import some Python libraries, 3 Python libraries to be precise. So the first library that we're going to import is NumPy as NP, which is the numeric library. The second library that we're going to import is scipy.stats as stats. So stats is the statistical module of the scipy library, and scipy is Python's scientific library. And then we're going to import matplotlib.pyplot as plt, which is the library that gives us our visualization. So we're going to define our variables. So sample size is 30, sample mean is 38, sample standard deviation is 5, hypothesized mean is 40, and confidence level is 95%. So the first thing we're going to do is we're going to set up our hypothesis test. So the null hypothesis is the population mean is 40 hours. The alternative hypothesis, the population mean is not 40 hours. So standard error is the sample standard deviation divided by the square root of the sample size. Your t-statistic equals the sample mean minus the hypothesized mean divided by the standard error. Your p-value, which is a probability, equals stats.t.sf, and SF stands for survival function, brackets np.abs, and that stands for absolute value of the t-statistic, comma, df equals sample size minus 1. So your sample size is 29 times 2, so it's a two-tailed test. And then your confidence interval is t critical equals stats.t.ppf and brackets 1 plus confidence level divided by 2, comma, df equals sample size minus 1. So your margin of error equals t critical times standard error. Your lower bound is your sample mean minus the margin of error, and your upper bound is the sample mean plus the margin of error. And then what we're going to do now is we're going to print the results. We're going to print the t-statistic, the p-value, and the 95% confidence interval. So your t-statistic is negative 2.19, and then and your p-value is 0.0366. Your 95% confidence level interval is 36.13 to 39.87, and basically what it is your p-value is less than 0.05. So what you have to do is you have to reject the null hypothesis. The company's claim is not valid. So the company is saying that they work 40 hours a week, but the confidence interval is between 36.13 and 39.87, and the mean is 38. So that means you reject the null hypothesis. That means that the mean of hours worked is not 40. So you have to go with the alternate hypothesis, and the alternate hypothesis is the mean hours worked is not 40. So what you have to do is we have the interpretation. So if the p-value is less than 0.05, so your alpha is 0.05 because you have a 95% confidence interval, and your significance level is 0.05, and that's also your alpha. So you're going to fail to reject the null hypothesis. You're going to reject the null hypothesis. The company's claim is not valid. Let's see what we see. And that's what it says here. That was the result that they gave. So it rejects the null hypothesis, but I knew that it rejected the null hypothesis even before it put it through the if-else statement, because the p-value was less than 0.05. So now what we're going to do is we're going to visualize the work, and so we're going to plot the confidence interval on a normal distribution. X equals np dot line space brackets sample mean minus 4 times standard error, comma, sample mean plus 4 times standard error, comma, 1000. And y equals stats.norm.pdf. PDF stands for probability distribution function, brackets x, comma, log equals sample mean, comma, scale equals standard error. So now we're going to plot it on a figure. So plt.figure brackets fig size equals 6, 4. So we're going to plot the sampling distribution curve. It's plt.plot brackets x, comma, y, comma, color equals blue, comma, label equals sampling distribution. So we're going to put some vertical lines on the chart just to identify some variables. So plt.axv line brackets lower bound, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound. plt.axv line brackets upper bound, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper bound. plt.axv line brackets sample mean, comma, color equals purple, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals sample mean. And plt.axv line brackets hypothesized mean, comma, color equals orange, comma, line style equals dotted, comma, line width equals 1.5, comma, label equals hypothesized mean. So now we're going to add labels, title, and legend to our chart. The title is Hypothesis Test and Confidence Interval for Mean Work Week. X label is hours worked, and Y label is density. You get a legend and you get a grid, and we're going to show it. So the hypothesis test and confidence interval for a mean work week. So the blue line is a normal distribution. The green line is your lower bound of 36.13. The red line is your upper bound of 39.87. Your purple dashed line is 38, and the dotted line is your hypothesized mean of 40. And so you can see that the employees, the 95% confidence interval, the employees do not work 40 hours a week. as the company has claimed. So that means that the null hypothesis has to be rejected. So that concludes this particular video and this particular section. And the next section, we're going to be talking about distributions for hypothesis testing. So I hope that you decide to watch that.